Unit 7, Quadrilaterals and Polygons. This is Unit 7, Day 2. We're going to talk about the properties of parallelograms. So here are 5 properties with a parallelogram. Opposite sides are going to be parallel. That goes with parallelogram. Opposite sides are going to be congruent. Opposite angles congruent. Consecutive angles are supplementary. And the diagonals bisect each other. So let's see what that looks like. Number 1, opposite sides are parallel. So let me put my little parallel notation here. Opposite sides are congruent. So I'm going to put my little tick marks. Opposite angles are congruent. So let me put my little arc. Consecutive angles are supplementary. 2 arcs. And then the diagonals, this is a diagonal. They actually bisect each other. So they're congruent parts as well. So now take some time, 2 minutes, go over all 5 properties of the parallelograms. When you think you know them, go ahead and share it with one of your table partners or share it with your teacher. All 5 properties. Every problem that we do, this is going to help us set it up. What's going to help us? Opposite angles are equal, go congruent. Opposite sides are congruent, diagonals bisect, or consecutive angles add up to 180. So this is what we're going to think through every time we come to a problem. So let's get started. So we're going to do some guided practice from page 5 and 6. So when I look at this, the directions say each quadrilateral below is a parallelogram. Yay! The properties are going to help us find the missing measures. Which properties will help us solve this? Well, I know that I have AB is 15, so opposite sides, that's going to help me. I know I have an angle, which is 68, so opposite angles, that's going to help me as well. So let's see what you can fill in. So take a look at this. What I would do first is I would write opposite sides are congruent, 15 and 15, 8 and 8. Opposite angles are congruent, 68 degrees and 68 degrees. And then the angles that are right next to each other, they add up to 180. They are supplementary, so this is 112, and the angle opposite is going to be the same. So that's what we're going to be doing with parallelograms. So before we get started, we always read the problem. The question, each quadrilateral below is a parallelogram. Yay, the properties are going to help us find the missing measures. Well, first I want to point out that they have given us some information, angle FED. When they give us angles as 3 letters, we want to concentrate on the one in the middle. So angle FED is going to be this entire angle right here. Not just the part that's 71, it is the whole thing. So the whole angle is 134 degrees. Which we know the other part has to be 63 degrees so that it adds up to 134. We also know that alternate interior angles are congruent when you have parallel lines. So that means this angle over here is also 71, and the angle over here is 63, and the total is, for the whole angle, is 134 degrees. Yay! We know that this angle over here is 21, so the alternate angle is going to be 21. We also know that angle E plus angle D is going to add up to 180. So let's see what we can do with that. So now we know that angle E is 134. Angle D, we don't know all of it, but they add up to 180. So that means angle D has to be 46 degrees. Well, we know that part of angle D is 21. So what could we do to find the other part? Exactly, we'll subtract 21 from 46. So we're going to come over here, we'll put it in blue. So this angle over here is 25 degrees, and the whole angle is 46 degrees. And if that's the case, this whole angle is 46 too, and this angle is 25. Alrighty, let's see if we can fill in the blanks. You try, and then push continue. Voila, here we go. So as I look at this, each quadrilateral is a parallelogram, so the properties are going to help us, and we're going to find all the missing measures. So which properties are going to help us solve this? The ones that have angles, opposite angles are going to be congruent, and consecutive angles will be supplementary. So let's fill in what we know. We're given that angle GHF is 34 degrees. That's that smaller angle in here. Alternate interior angles are congruent, so that's also 34 degrees. We also are given that HJF is 124. H to J to F, concentrate on the middle letter, so J is 124. So the angle opposite is also 124. We're also given that angle FKJ is 79 degrees. We're concentrating on K to see where it goes. So that's that angle in here. We know vertical angles are congruent, so we could definitely put 79 here. We know that 3 angles in a triangle add up to 180, so we should be able to figure out the rest of the information. Give it a try and see what you get. All right, here are the answers here. If you don't understand any of these, pull one of your teachers in the room and get them to explain it. Which property is going to help us solve this? Well, let me look at T to V. Well, T to V looks like it's a diagonal, and W to V, part of a diagonal. So what's going to help us is knowing the property that the diagonals bisect. So let's fill in what we know. From T to V is 74. And since the diagonals bisect, each part is going to be 37. W to V is also 4x plus 1. 4x plus 1. So what we know is that the diagonals bisect, so 37 is going to be the same as 4x plus 1. Try your algebra out and let's see if you're correct. Alrighty, and x is equal to 9. So which one of our properties is going to help us with this? Well, this is an angle, so it's either going to be opposite angles are congruent, supplementary, if they're consecutive. So we just got to be mindful of the properties that go with angles. So when I look here, they're giving me that this angle over here is 25. That means this alternate interior angle over here is also 25. It's telling us that KLH, remember we concentrate on the middle letter when we have 3. So from K to L to H, which is this whole angle right here, is 134 degrees. So what we know is that angle K and L are right next to each other, so they add up to 180. So angle K is made up of 2 angles, smaller angles, which is 4x plus 9 plus 25. And angle L is made up of 134. And we're going to set that equal to 180. Go ahead and give your algebra a whirl, and let's see what you get. Combining like terms, we get the final answer is x is equal to 3. So we will be graphing in this unit, and so if we have to graph and we have to put things on the coordinate plane, we will be able to prove both pairs of opposite sides are congruent if AB, side AB is congruent to side DC, or and side DA is congruent to side BC. Now, how will we do that? Oh, we would use the distance formula. If we want to prove both pairs of opposite sides are parallel, what do we do? So if we're going for proving parallel, AB will be parallel to DC and DA will be parallel to BC. You're definitely going to have to use the slope formula. Rise over run. And last but not least, we can prove one pair of opposite sides are congruent and parallel. Then we can definitely use the same pair, just show that they're parallel and show that they have the same slope. This one is probably my favorite one. Alrighty. So for this particular slide, we're going to prove the figure is a parallelogram or not, and we're going to use a distance formula. So basically what we're going to need is we use a distance formula from A to B using the coordinates from A to B, and we get it down to the square root of 68. You try BC and then hit play when you're ready to check your answer. And we get the square root of 164. After using the distance formula, we get the square root of 68. Last but not least, we get the square root of 164. Clearly, we can see that we have 2 sides that are equal to each other. So what can we say? We could say, yes, this is a parallelogram. So for this particular one, number 3, it says determine whether the figure is a parallelogram, but this time we're going to use the slope formula. So for the first one, the slope of wx, we put our y's together, we put our x's together, and we subtract them. We simplified it to get negative 2 over 8, and we simplified that to get negative 1/4. So the slope of wx is negative 1/4. You find the slope of xy and then check back in. Slope formula is at the top. There's the slope of xy. Check back in after you've done yz and wz. So we have all the slopes. Do we have opposite sides are parallel? Well, definitely these two sides are parallel, but the other two are not. So we're going to have to say no. It's not a parallelogram. Get started with your independent practice after you've done a couple of problems in this section. Thank you.